Very good morning to all. My name is Sneha Sule, working as an assistant professor in CSIT department. Today I am going to teach you all on the topic sorting, which is a topic in subject ADA, that is analysis and design of algorithm, and it is taught in semester 4 in CSIT department. So let's switch to see what is sorting. A sorting algorithm, it is used to arrange a given array or list of elements according to a comparison operator on the elements. So what is sorting? Sorting is generally you are arranging a given list of elements in an array in either ascending or descending order depending upon some criteria. So that criteria, it is called as comparison operator. So the comparison operator, it is used to decide the new order of elements in the respective data structure. The comparison operator is some criteria depending upon which we will arrange the elements. So this is one example of sorting algorithm. Here we have given a list of unsorted elements that is starting with 170 and ending with 66. Total there are 8 elements in an array. Now applying different types of algorithm, the output which we will get will be 2, 24, 45, 66, 75, 90, 170, 802. With 2 being the minimum value, it is in the leftmost position, and 802 being the maximum value is positioned to the rightmost element. Here we have implemented sorting algorithm depending upon the criteria ascending values. That is 2 is having the minimum value and 802 is having the maximum value. So there are different algorithms to arrange your elements in sorting algorithm. Among those, today we are going to study on the algorithm which is selection sort. So what is selection sort? In selection sort, we are given list of elements. In those elements, we will select the value which is having minimum place, and that selected value will get replaced with the first position. We will start by finding the smallest entry. Here we have taken one example in the graph format. 1, 2, 3, 4, 5, 6 as the bar graph, with fifth position is having the minimum value and fourth position is having the maximum value. But always in selection sort, we will start comparing it with the first position with all other elements. Here we are comparing one position with 2, 3, 4, 5 and 6. So after comparison, it is seen that one will be fifth position is having the minimum value. So what we are doing, we are just swapping the fifth with the first position and first with the fifth position. Why we are swapping? Because fifth is having the minimum value. So after swapping, your output will be, see here you can see that one with yellow color is positioned to the first, and that first position value is positioned to the fifth. So now one is sorted, 2, 3, 4, 5, 6 values is unsorted value. So here we are getting that we are positioned to second. Second will get compared with third, fourth, fifth, and sixth. So here you can see that 6 is having minimum value in comparison with second. So what we will do, again we will swap the second value with the sixth value. So the output will be smallest from unsorted is the sixth position. So output will be 1, 2, 3, 4, 5, 6. So this process will continue until and unless we get the entire value in ascending order. So here you can see that the process keeps adding one more number to the sorted side. The sorted side will have the smallest position to the leftmost and highest value to the rightmost. So here you can see that fifth and sixth will now be compared, as fifth is having maximum value. So fifth position will get replaced with 6 and 6 with fifth. So this will be the output. So now here we are getting the entire graph in sorted form. So this is the position where we are going to stop. So this is the algorithm that helps you to arrange your elements in sorted format. So in next slide, we are going to see how we are going to implement it practically. Means if we are executing it, how we are going to write it in a program. So this is the program of selection sort algorithm. In selection sort algorithm, we have taken one method, void selection sort, in which two variables are passed, int array and int n. Int array is used to declare the array which we are going to sort, and int n is a variable which is used to give you the number of elements which will be there in the array. In method, now getting inside the method, here we have used I, j, min, id, x. These are the variables having data type integer. So I variable is declared because we are using two loops, outer loop and inner loop. Outer loop is used to set the number of elements or set the elements in the given array, and J loop is used as a comparison to check each elements in the given array, and minimum IDX is the variable to set the minimum value for the given element in the array. So one by one, we will move to the boundary of unsorted subarray. Here we are outer loop. For I, we will start with I equals to 0 to I less than n minus 1 to I plus plus. By this outer loop, we will get the entire list of elements which will be there in the array. Inside that array, we will set the minimum value as starting value as minimum. That is why we have used minimum IDX equals to I. In the next, what will be the position? Now we are going to check the minimum value in the elements. That is why J loop is the innermost loop, which will start with J equals to I plus 1, J less than N, J plus plus. In this, we are using comparison operator, that J value will get compared with the value which is set as minimum. If that J value is having minimum value in comparison with the value which is already set as minimum, then what we are going to see, we are just going to assign J as value to minimum IDX variable. Okay. So here we have used, if array of J is less than array of min IDX, then minimum IDX will be equals to J. After that, what we will be doing, we are just going to swap that value with the minimum value. If minimum IDX not equals to I, then swap array mean of IDX, comma array of I. So swapping will be done at this position. Now, this procedure will continue until we get the values in sorted format. So that element, if we are getting the entire value in sorted format, then that values should get printed on the screen also. For that, we are writing function void print array, int size, int I equals to 0, I less than size, I plus plus. Now, here we are getting the values in printed format, cout array of I. Okay. So this void print of array is generally, this function is used to get the values in output in the values in the form of sorted format. Now we are just taking one example. That example values will be passed through main function. That is why we have declared one int main. We have declared one array which is in unsorted format having 5 elements, 64, 25, 12, 22, 11. Next, we are getting this how much size is of that array. Int n equals to size of array divided by size of array. Okay, then we are making function call to selection sort, and then we will get the output in sorted format. So your output after applying this entire program will be, sorted array will be 11, 12, 22, 25 and 64. Now next will be to get the complexity analysis. So complexity analysis means how much of running time will be there for selection sort. So here we are using two loops, I loop and J loop. So to traverse the I loop, we will be requiring O into N value. And to traverse the J loop, we will require O into N time. So total overall complexity will be O of N into O of N equals to O of N square. Why O of N square? Because we are using two nested loop. One loop is used to get the outermost, to get the list of elements, and the second loop is used to get the comparison between the values in the given array. That is why O of N into O of N square. So this is the time complexity of selection sort. So that's it from today's class. Okay, thank you students.